One good day pre-algebra. Starting Unit 2 with PO7, comparing and ordering rational numbers. Now in Unit 1, we talked about what rational numbers are. They are whole numbers, they're integers, they're decimals, they're fractions. We're taking a look at these values and ordering them, okay? Least to greatest usually. We are compartmentalizing a little bit in that we're going to focus on integers only, and then decimals only, and then fractions only. But then ultimately kind of put them all together, and if you're given integers or decimals or fractions, whatever it is, especially since we talked about how to convert between decimal and fraction, you'll be able to put them in least to greatest order. So if we're going to be using these symbols, it's going to be helpful to know what they mean. What does this first symbol in this little table mean, Cade? It is not greater than. The first symbol means less than. Okay, and this one would mean greater than. There are several different methods out there for how to tell the difference between less than and greater than, but who would like to share one that has worked for you? Okay, and just because it works for you doesn't mean it has to work for everybody, right? But what has worked for you to know the difference between those two symbols? Dayton. Okay, so for example, the less than symbol here, how do you know that the fact that it's pointing to the left means less than? Okay, in reference to a number line, like for the left you go, the lesser your values get. Good. Griffin? Okay, shark or the alligator might be the other one, right? It kind of eats that larger value. Good. Haley? But so if I give you 5 and 10 and ask you to put the symbol in between those, you can say in your head 5 is less than 10, but how do you know that this is the less than symbol versus the other one? Okay, good. Cade?
Even though I got it wrong, since it's like that, it kind of looks like an L.
That's actually the one that made the most sense to me growing up too. If you take an L and you kind of squoosh it together, you get the less than symbol, right? So that's kind of what I used, growing up there. But whatever works for you is great. But know the difference between those two symbols, whether it's the pointing or the alligator or the shark or the L, whatever it is. All right. Then, of course, that third symbol is the equal to symbol. It is used to show that two values are the same. Two values are the same. Okay. Here's kind of your objective cheat sheet. This would be really good to put on a help sheet for the test. It kind of summarizes each of the concepts that we're going to talk about today. For integers, it's going to be helpful to use a number line. Visualize where on the number line each number is. And as Dayton said, the further to the left you are, the lesser the values are. For fractions, we kind of talked about two of them. We're going to talk about comparing values to 0, 1/2, or 1. For example, I know that 7/12 is greater than 4/11 because what's half of 12? 6. I've got 7. I've got more than half. What's half of 11? Yes, 5.5. I've got 4. I've got less than half. Obviously, something that's more than a half is going to be greater than something that's less than a half, right? So if you got to think about your fraction values in relation to these common fractions, that can help you determine order. Or you can use equivalent fractions using the whole common denominator method. Those of you that have worked with me over the summer, we talk about thinking about those as test scores. That could be helpful, okay? And then for decimals, we talk about the stacking method, which every time that I show it, everyone's like, oh yeah, I know how to do that, right? So you've seen these before, but now it's kind of putting it all together in one objective, and so we can move forward, okay? One of the most dangerous things, yet somehow most common things students do when ordering fractions is to look at how far away the denominator is from the numerator. That is, what word adequately describes this? The method is tragic. The fact that it even exists. Okay, there are some real tragedies in our world. This is near the top of the list for me right here. Okay, you would never, at least I hope not, you would never tell me that 2/5 is equal to 37/40 because they're both 3 away, right? 2 is 3 away from 5, 37 is 3 away from 40. But clearly those are different fractions, right? We're on the same page here. If you got a test score back that was 2 out of 5, that's not going home, right? That's going in the bottom of the locker. I lost it. Whoops, sorry, parents. Don't get to see it, right? Whereas 37 out of 40, growing up for me, that was going up in the fridge, right? So if you try and tell me that you're making a decision based on how far your numerator and denominator are, I don't know what I'm going to do. I mean, gray hairs start popping out, tears start flowing, whatever it is. Okay, so watch out for that. But let's start with integers. It says compare using less than, greater than, or equal to. Raise your hand. -7 and -10. What symbol is going in between those numbers? Camille. Greater than. -7 is greater than -10. And we talked about using a number line to help us here. You don't necessarily have to write this out, but thinking of a number line, let's put 0 here. I'm dealing with negative values. I'm going to put my 0 kind of over on the right side, so I'm not going to have to go positive. But where is -7 and where is -10? Well, -7 is -7 is 7 units away from 0. -10 is 10 units away from 0, right? And as Dayton said, well, the further to the left you are, the lesser the values are. We can kind of re-say that to say the further to the right you are, the greater the values are, right? So -7 being further to the right on the number line is going to be greater than -10. Yeah? Yeah, good. Abby? Sure. -4 and +2. Less than. This is kind of straightforward because obviously any negative number is going to be less than any positive number. Okay. For the same reason we talked about here, negatives are further to the left on the number line than positives are. All right. -2 and -9. What symbol is going in there? -2 compared to -9. Tony? -2 is greater than -9. Good. Okay. We're going to pause the video. I want to have you work through the next 5. We'll come back, answer some questions. And so until moments from now, toodles. And we are back recording. Raise your hand. -14 compared to -12. What do you get? Tony? Less than -12. It's further to the left on the number line. 19 is, Haley? Less than 22. It is lefter on the number line. Is that a thing? No. Being lefter? I don't think it is. 8 is Dayton. Greater than -8. Any positively greater than any negative. -16 is Sophie. Less than -13. It's further to the left on the number line. And -65 is Carter. Less than -53. It's further to the left on the number line. Okay. The next 3 is going to be part of your homework. So if you've already done them, good for you. If not, then you can do those. It's ordering several values at a time from least to greatest. And here's where a number line might really come in handy. Draw one, plot them all on it, and then you can see, from left to right, which one's going to be least and which one will be the greatest. Questions on integers? Your key is going to be that number line there. Okay. Let's move on to decimals. Again, we're using the less than, greater than, or equal to symbol. How would you compare 0.223 with 0.793? What method, what thought process would you use for this? 0.223 with 0.793. Lexi. Sure, you can just use place value, right? As soon as you compare, they have the same number of holes. They both have 0, so we can move on to the next one there. But then we go to tenths, and we're comparing 2/10 with 7/10. Does it matter what comes after that? No. right there in that 10th spot, you can say, oh, okay, because this is 2/10 compared with 7/10, that's going to be less. Doesn't matter what happens afterwards. Okay. The next one, 67.4 compared with 63.22. What's your thought process for ordering or for comparing those? What symbols going in between them, and how do you know? Tony? Greater than. Why?
Because 7 is greater than 3.
Yeah, again, you start with place value. Start at the left. They both have the same number of tens. We're both talking about something in the 60s here, right? But then you look at the ones, and you've got a 7 compared with a 3. 67 is greater than 63. Doesn't matter what comes after that. Okay? How about 2.54 and 2.5400? Kate, they are equal to. Okay? A not so secret about decimals is that you can add zeros on the end of it forever, and it doesn't change the value, right? Because if I ask you, how many holes does this have? Well, they both have 2. How many tenths do they have? They both have 5 tenths. How many hundredths do they have? They both have 4 hundredths. How many thousandths do they have? Well, they both have 0 thousandths. It's just in here we wrote the 0, and the first decimal we didn't. Still aren't any there. Okay, so they are equal. How about 0.27 and 0.3? Camille, it is less than. And here's where folks make the biggest mistakes with ordering decimals, is they look at this and they think about it as 27 and 3. But it's not 27 and 3, is it? What is it really, Annie?
Like, you could add zeros onto the 3 for like ever.
Yeah. You should only be comparing decimals like that if they're out the same number of places. So that 0.27, which is out to the hundredths place, I should not be comparing 27 with 3, because 3 is only out to the tenths place. As Annie said, I can add a 0 here, and now that they're both out to the hundredths place, it's not 27 and 3 anymore. What is it? 27 and 30, right? And 27 is less than 30. Okay? Again, you can use place value here, because right when we get to this 10th spot, 2 is less than 3, right? Doesn't matter what happens after that. 2/10 is less than 3/10. Okay? But this method right here is called the stacking method, where we vertically align them, fill them out with zeros till they're all the same, and then we can compare, for example, like this, 27 and 30. Kate, question?
Do I have to like stack them, or I just add a 0 to it?
If you can do it without stacking, that's great. Okay? If you need a visual and organized thing, stacking helps. All right? Again, we're going to pause the video, work through these next 4. We'll talk about them shortly. All right, here we go. Looking at these 4, 1.34 and 1.5, what goes in the middle? Anybody?
Greater than. Less than. Wait, I'm looking at the wrong one. Sorry, I was looking at the bottom here.
Okay.
I was looking at the
1.34 is less than 1.5. If you use the stacking method as a visual, we're comparing 34 with 50. You can also look at place value. They got the same number of holes. As soon as we get to the tenths, though, 3 is less than 5. Okay, and so it's going to be less than. 2.361, 2.365. Same number of holes, same number of tenths, same number of hundredths. But, Kate, 1,000th is less than 5,000th. So it's going to be less than symbol. 3.01 and 3.001, Colin? Greater than, okay? Zeros in between numbers, they count, okay? We have to include them. We can't just get rid of them. So it's as if we have, using the stacking method here, 0.010 versus 0.001, right? That 1/100th is greater than no hundredths, okay? And finally, 10.999 and 10.9990, Kylie, equal to. Add that 0 on the end of it. It doesn't make a difference, okay? Questions on decimals? Or did I get my point across? The decimal point. Pointing. Your homework, part of it is going to be to do the decimal section down below here. Some of you have already started on that. Great. But if you haven't, then that's going to be your homework for tomorrow. Finally, fractions. We've got a couple different methods that we talked about here. How would you go about 3/6 and 5/10? What's the relationship there, and what would you do to get that? Blake? They are equal. And how'd you know that? Okay, so one method you can use for fractions is to simplify them, right? Yeah. There you are. Okay. If you simplify 3/6, you get 1/2. If you simplify 5/10, you also get 1/2. That's the thing about equivalency, equivalent fractions. Even though these numbers are completely different, right? They have the same value. They're both equal to 1/2. Sir?
Couldn't you also multiply the denominators to get common denominators?
If you wanted to get common denominators, you probably go to 30, right? So then that would change your first fraction to 15/30. Your second fraction would also become 15/30. And because they're exactly the same, you can compare them that way too. Yep, perfect. 3/8 and 7/12. What do you think, and how'd you come up with it? They're both 5 away, right? So they must be equal, right? No. What symbol would you put in between them, and how would you figure it out, Haley? Why is 3/8 less than 7/12? Okay, so using common denominators here, we can rewrite 3/8 out of 24ths by multiplying by 3 and 3. Gives us 9 24ths. 7/12, we'd multiply by 2 and 2, and that gives us 14 24ths, and 9 24ths is less than 14 24ths. Anybody use a different method? Let's think about these fractions compared to 1/2. With the denominator of 8, what's half of 8? 4. Is 3 less than that or greater than that? Less than, right? So 3/8 I know is less than 1/2. Because half of 8 would be 4. I only have 3. So it's below that. What's half of 12? 6. I've got 7. Is that more or less than half? More, right? So if I've got one fraction that looks like a 7.5. If I've got one fraction that's less than 1/2 and one fraction that's greater than 1/2, obviously my 3/8 is going to be less. Okay, so that's an example of comparing each of those fractions to, in this case, 1/2. I know that 3/8 is less than half. I know that 7/12 is greater than half. So 3/8 is going to be less than 7/12. That's another method you could use. Kind of more of a mental logic method compared to calculating here. Get the same answer, so either one's fine. But yeah.
For the mixed number one, we just do 4 times 2 plus 3 and then get our answer.
Yes, to convert to an improper fraction, you would be denominator times whole plus numerator. 5/11 and 14/33. What's the relationship, and how'd you find it? Cole. Okay. So what did you come up with as an answer then? Sorry? Greater than? Okay. And how'd you use 33 to get to that answer? How could you use 33? Colin? Yeah, we can rewrite 5/11 to be out of 33 by multiplying by 3 and 3. That gives us 15/33. Our other fraction is already out of 33, and 15 is greater than 14. Okay. 9/5 and 7/3. Let's talk about this last one here. 9/5 and 7/3. What's the relationship, and how'd you know? They're both 4 away, right? So they're equal? No. Wyatt, why is 9/5 less than 7/3?
Because if you multiply 5 by 3, you get 15 to the denominator, 3
Yeah, we could go the common denominator route again. Sometimes people say, well, 9's bigger than 7 and 5's bigger than 3, so the fraction must be bigger. That's not really how fractions work, right? Fractions are parts of wholes. As a mixed number, what's 9/5? Yeah, what's in this improper fraction? 9/5 as a mixed number. How many times does 5 go into 9? And what's left over, Haley? 1 and 4/5, right? 5 goes into 9 one whole time with 4/5 left over. How many times does 3 go into 7? 2. So just by looking at that and saying 5 only goes into 9 once, 3 goes into 7 twice, that means this is going to be at least 2 wholes compared to 1 and 4/5, which is only 1 whole, right? This ends up being 2 and a third here. But something that is only 1 whole is going to be less than something that is 2 wholes. So just, again, logically thinking about these fraction values. 5 goes into 9 once, 3 goes into 7 twice, 9/5 would be less than 7/3. Okay? Do the bottom row, those 4 on your own. We'll talk about them in mere moments. We're back going over the fractions quickly here. 4/5 and 7/9. Tell me the relationship and how you found it. Kylie, why do you say that? Okay, so going with that common denominator of 45, which really is, if you're not going to think about a lot, this is the cleanest way to do it. You know, it works every single time. Multiply by 9, and by 9 to get to 45, that's 36 45ths. Multiply by 5 and by 5, that's 35 45ths. Awfully close in value, but 36 45ths is greater than 35 45ths. 13/4 and 2 3/4. What'd you come up with for that? And how'd you find it, Blake? Why is 13/4 greater than 2 3/4? Common denominators, okay? And you, I mean, they're already common. So how did you use common denominators here? Like 13/4 and 2 3/4, you already have a denominator 4. So how would you use that to help you make your determination? Did you maybe convert them both into mixed numbers or into improper fractions? Okay. Okay. Griffin. Okay, so 4 goes into 13 3 whole times. That gives us 12. So you have 1/4 left over. And then we're comparing that with 2 3/4. So 3 wholes is going to be greater than 2 wholes. Doesn't matter what the fraction is, right? If you converted 2 3/4 to an improper fraction, then you'd have 13/4 and 11/4. And 13/4 is going to be greater than 11/4. So either way you slice it, greater than. 2/7 and 21/77, Cade. Why? All right, so common denominators. Multiply by 11 to get that 77. And then this is already out of 77, and 22/77 is greater than 21/77. Lastly, 3/14 and 19/84. That's the year I was born, 1984. I probably did that on purpose. Haley. Yeah, so the scale factor from 1484 is 6. So we only have to multiply one fraction. We're going to multiply by 6 and by 6. That gives us 18/84 compared with 19/84. And so 18/84 is less than 19/84, less than symbol. Okay? Your homework for tomorrow. You have the rest of the integers on the first page. You have the decimals at the top of the page. And then you've got now a combo platter. You've got one set of 4 fractions, one set of 5 decimals, and then some fractions and decimals mixed. Remember, you do know how to convert between decimals and fractions here. Okay? It might help you to put them all in the same type of value first. convert all your decimals to fractions, convert all your fractions to decimals. Maybe you can do without doing that. We'll see. Okay, but this is due tomorrow. PO7, that is how you math.